The era of commercial space travel has begun, and the time has come for people all over the world to go to space. It is known that when ordinary space travelers go to space, there is a demand to drink chilled carbonated beverages such as champagne and beer in space. Therefore, ASTRAX is developing various technologies necessary for drinking chilled carbonated beverages in space and zero-gravity environments. In this paper, we will present the technologies and challenges for drinking chilled carbonated beverages, champagne, beer, etc., in space. 1. Introduction. ASTRAX is developing a space beer that can be consumed in space in collaboration with a Japanese company called Space Wamama. In order to drink beer, carbonated beverage, in space, including zero-gravity environment, it is necessary to solve various problems. Therefore, in order to realize beer drinking in space, we will summarize the technological development and issues from the viewpoint of how to drink various carbonated beverages including beer in space in Section 2. 2. Demand for carbonated beverages in space. Drinks that have been approved as space food include water, powdered milk, powdered juice, chocolate drinks, tea, and coffee, all of which are served at room temperature. It is known that astronauts' demand for cold and carbonated beverages are desired. However, both of these requests are low on the priority list and have not been realized. On the other hand, as the number of space travelers who are neither astronauts running a spacecraft nor working in space increases, it is easy to imagine that more and more people will demand not only cold and carbonated beverages, but also champagne, beer, and other alcoholic beverages. Therefore, we will summarize the results of a study of the technologies and issues for providing cold carbonated beverages, especially alcoholic beverages, which are being developed by ASTRAX, a service provider for space travelers, with and without zero gravity and for each commercial spacecraft. 3. Carbonated beverages and space environment. 3.1. Commercial spacecraft without zero gravity. In the case of commercial spacecraft that do not experience zero gravity, such as the balloon-based stratospheric spacecraft of Space Perspective and Worldview Enterprises, carbonated beverages could be served to the passengers in the same way as on the ground, since the inside of the spacecraft remains almost at 1 g. The only limitation would be the weight of the spacecraft and the space required for storage. Since these spacecrafts were originally developed with the expectation of serving wine, champagne, and other alcoholic beverages in the sky, the only thing ASTRAX needs to consider is to make adjustments to accommodate beverages that match the passengers' preferences, or those of the mission. ASTRAX is developing this service with the assumption that it will serve alcoholic beverages such as wine and champagne. 3.2. Commercial spacecraft with zero gravity. In the case of a commercial spacecraft, such as SpaceX's Crew Dragon, which will be in zero gravity for a long period of time, the liquid will stick to the glass or mug because surface tension will cause the liquid to be attracted to anything with a surface in zero gravity during orbital flight. In addition, when liquid is poured from a server into a glass or mug, it must be pushed out with moderate force because it tends to scatter in zero gravity conditions. Furthermore, if the glass or mug is specially shaped for zero gravity, it is necessary to consider how to pour and drink accordingly. Liquid beverages that NASA astronauts drink in space usually come in a packet and are consumed through a straw. They would stick a needle attached to a special dispenser into the drink packet, fill it with water or hot water, dissolve the powdered drink element, mix it, and drink it through a straw. However, if a space traveler who has paid a lot of money for a trip to space is going to drink a drink in space, much less a carbonated beverage such as champagne, it would be better to be able to drink in a way that is unique to space and also cool and stylish, rather than just chugging it down with a pack. It is necessary to consider glasses, mugs, dispensers, servers, etc. that can reliably serve the beverage to the passengers and enable them to drink in a cool and stylish way, while taking into account the behavior of liquids in zero gravity, such as surface tension and pouring difficulties. 3.3. Carbonated beverages and zero gravity. Carbonated beverages are drinks in which carbon dioxide is dissolved in liquid at high pressure and sealed in bottles, cans, etc. Carbon dioxide cannot be dissolved in liquid unless it is under high pressure. When the sealed bottle or can is opened to drink the carbonated beverage, the pressure is reduced and the carbon dioxide is released in the form of bubbles and shrieks. On the ground, the bubbles rise up in the liquid due to buoyancy and move out of the liquid surface before they become very large. However, if a liquid containing carbon dioxide is kept in a zero-gravity state, the bubbles do not rise due to buoyancy and remain in the liquid, and the liquid quickly becomes filled with bubbles. The bubbles then stick together one after another and become large bubbles. As a result, the carbonated beverage around the bubbles is pushed out of the container and violently blown out of the container. Therefore, it is necessary to maintain the pressure to the extent that the carbonation does not vaporize as much as possible, and only open the mouthpiece to drink when necessary. 3.4. Body behavior when drinking a carbonated beverage in space or zero gravity. What happens in the stomach when drinking a carbonated beverage in space, zero gravity? In normal life on the ground, when the stomach is full of gas, air rises in the stomach and is naturally expelled as a burp. However, in the zero-gravity conditions of space, liquid and gas will mix even in the stomach, so the stomach will not burp and the person will suffer with a bloated stomach. There are two solutions to this problem. First, before drinking, turn the container around and use the principle of centrifugal separation to firmly separate the air from the liquid and drink only the liquid. After drinking, the air rises up in the stomach and the liquid is moved around a little more. This will cause the air to rise up in the stomach and make the person burp. See reference material, 93. In any case, the space environment, or zero-gravity environment, is a very important factor. In any case, if carbonated beverages are to be served to passengers in a space environment, or zero-gravity environment, it will be necessary to give them a lecture including precautions for drinking carbonated beverages and what to do after drinking them. Section 4 summarizes past Coca-Cola and Pepsi-Cola experiments conducted on NASA's Space Shuttle in the Coca-Cola Space Dispenser, as well as champagne experiments conducted by a private French company using a weightless plane and beer experiments conducted by a private Australian company. However, I will omit them in this presentation to save time. If you are interested in those experiments, please refer to the paper. 5. Subject: Beverages of the experiment. ASTRAX is conducting research to make it possible in the future to provide all kinds of beverages such as water, coffee, juice, alcohol, etc. on board spacecraft for space travel services. Based on the experience of various experiments of carbonated beverages such as beer and champagne in space, ASTRAX is developing and studying the following technologies to enable the chilling and serving of alcoholic carbonated beverages such as beer and champagne in space, according to the characteristics of the spacecraft. Beverage storage methods. Consideration of refrigerators for storing cold beverages. Consideration of servers, dispensers, with cooling function. How to serve beverages. Development of glasses and mugs to hold drinks. How to drink, including physical handling after drinking. How to dispose of leftover drinks. How to wash glasses. How to store and refill carbonated drinks, etc. 6.1. Creation of servers and bottles for space use. For initial short-duration space travel, it would be easier to attach a special device to each bottle to pour, or drink directly from the bottle with the mouth, than to prepare a dedicated dispenser, server. However, ASTRAX has yet to develop servers and bottles that can be used in space, or zero-gravity environment. First, the company is in the process of designing a space-inspired label and making the bottle itself. In the future, the company plans to develop a special container and conduct experiments in zero-gravity flight to make it usable in space. 6.2. Production of glasses and mugs. ASTRAX has cooperated in the development of cocktail glasses for space use by the U.S. Zero-Gravity Cocktail Project, and actual zero-gravity flight experiments were conducted by ASTRAX. Also, referring to the Zero-Gravity Cocktail Project mentioned above and the technology developed for the Space Coffee Cup developed by Dr. Mark Weiselogel and tested on the International Space Station, several types of glasses and beer mugs are currently being produced. See separate paper for details. 81. We are planning to conduct zero-gravity flight experiments in order to confirm the effect and influence of these shapes of glasses and mugs for drinking carbonated beverages in zero-gravity conditions. 6.3. Cooling methods. 6.3.1. For spacecraft with gravity. For cooling during short-duration space travel in a spacecraft with gravity, such as stratospheric space travel in a balloon, simply keep ice and drinks in a cooler box and provide them in space, e.g., in the stratosphere. Alternatively, galley facilities like those in aircraft would be even better. However, considering the cost-effectiveness with flight time, weight and cost of equipment, simply a cooler box may be sufficient. If ice in a cooler box is not enough, an electric cooler box with cooling function may be useful. Battery-powered or even solar-powered might be acceptable. 6.3.2. For zero-gravity spacecraft. 1. For short-duration spaceflight. In the case of a short spaceflight, where the duration of stay in space is only a few minutes and drinks are to be consumed, it would be sufficient to provide them in the manner described in section 6.1. In addition, for cooling, it would be sufficient to cool them in the manner shown in section 6.3.1. 2. For long-duration stay spaceflight. In the case of a long-duration stay spacecraft, in which the interior of the spacecraft is in zero gravity, the spacecraft may be cooled by a refrigerator so that cold drinks are always available, or a system that allows rapid cooling only when drinking to conserve electricity may be provided. ASTRAX plans to develop the system for both cases. 6.4. Importance of objective over technology. In normal space development, technology development is often conducted from the viewpoint of whether or not the activity itself is feasible or to improve the quality of life in space for astronauts, regardless of the purpose of the activity. For example, the development of Coke for drinking in space may be aimed at the development of technology to provide carbonated beverages in zero gravity, or the promotion of the development company, or the need for space food on the menu for astronauts, and so on. ASTRAX's development, on the other hand, is aimed at the needs of the passengers, customers, and the success of the mission. For example, a couple may want to toast with a glass of wine after a wedding ceremony or anniversary in space. A couple may want to shoot an impactful image with a carbonated beverage for a commercial filming. A fashion model may need a drink scene as one of her poses for a photo shoot, or a couple may want to have a delicious meal while enjoying a great view of the sky. Or, you want to drink a glass of champagne when you eat a delicious meal with a great view, or you want to drink a drink in a glass that cannot be found on the ground because you have paid a lot of money to travel in space. In that sense, in some cases, the development may be for ad hoc purposes. However, this is often rather more important for the average customer. This is because the initial customers value the fulfillment of a unique and original mission or dream more than a generalized one. 7. Conclusion. ASTRAX will continue to research and develop various space beverages, including carbonated beverages such as space beer and space champagne, for the various needs of different customers. First, we aim to be able to experiment and provide services in ASTRAX's zero-gravity flight service. Ultimately, ASTRAX will continue its research and service development to provide all types of beverages in space for all ASTRAX customers.